Welcome to this video where we talk about what a series is, and we actually talked a little bit about what a series is in the previous question already, right, where you got a glimpse as to what a series is. But in this video, I want to formally define for you what a sequence is. But before that, let's just recap. What is a sequence? What we learned before. So a sequence is just an ordered set of numbers. So there are two key parts to this definition, which is ordered, right? They are not randomly jumbled up. They are not just anyhow arranged. Right, there's a specific order defined by the set, right? The order can be a difference of constant or it can be multiple, right? So there's many different ways as long as there's some sort of relationship and rule in which they are being ordered. Second one is a set, so it's a set of numbers. Now, a series is just the sum of the terms in a sequence. So a series is just terms in a sequence and then you add it up. So I give you an example here. So let's say A is an ordered set of numbers. For instance, this is 2, 4, 8, 16, 32. There's some sort of order over here because each is just a multiple of, you just times 2, then you get the next number after that. And then here to here is also times 2, right? So from here, we can infer that the general term of this sequence, so far we know that this is a sequence, right, is starting from 2. Okay, I'm just going to give it to you, the general term, but later on you actually learn how to formally go and calculate what's the general term, right? But the general term, we typically call it Tn, or we can call it Un, right? Tn or Un, but I'm just going to call it Tn, right? So the Tn is just 2 times 2 to the power of n minus 1. Okay, so we just put it that way, right? Or you can further simplify this to just give you the power of n over here. Okay, so this is T1, T2, T3, T4, T5. And we also learned previously that a sequence got two types, right? It can either be an infinite sequence or a finite sequence. And over here, I'm just going to let n take on any positive real integer. And therefore, we know that this is an infinite sequence because it never ends, right? It contains an infinite number of terms. So let's say I let Sn be the sum of the first n terms. So U1 equals to S1, right? Or rather, I can just say that S1 is U1. S2 is basically U2 plus U1. S3 is U3 plus U2 plus U1. And then, of course, we can go on and on with this whole thing. So this over here, right, this is just 2. This is 4 plus 2. This is 8 plus 4 plus 2. This over here and this over here, they are all what we call a series because they are the sum of the terms in a sequence, right? So it's a series as they are the sum of the terms in a sequence. So in short, whenever we have a sequence and we add up the terms in a sequence together. So for instance, if we add up the first 3 terms together, they form a series. So sometimes you may hear saying a series of terms. That basically means the sum of the terms in a sequence. So this is the formal definition of what a series is. A series is simply just the sum of the terms in a sequence. And you can be very specific when you talk about series. You can say the sum of the first term, the sum of the first 3 terms, the sum of the first 10 terms. They are all considered as a series each. And that's it for this formal definition of a series. Okay, got any other questions? Let me know in the comments below. We will break down this question that basically gives you the opportunity to practice your understanding of what a sequence and a series is each. Now, I'm going to give you the opportunity to try this question first. So pause this video to attempt this question. If not, right now, we are going to jump right into this question and break down how we actually derive the answers as you can see on the screen. So we have the sum of the first n terms of a sequence, right? So let's just define the question first. The sum of the first n terms of a sequence, this is essentially what we call a series, right? And the formula for this over here is Pn plus Qn squared. Now, we don't really need to care so much about how the formula is being derived, but we just know that there is a formula to calculate the sum of the first n terms. And just note that this is very different from the general term. So note that this is not the same as the general term Tn of a sequence. This over here is a formula for series. This over here is a formula for sequence. So you can think of it as the general term is the formula to derive a term in the sequence. But this formula that I just circled is the formula to calculate the value of a series. Okay, and it's given to us that S2 is 8 and S5 is 35. So how do we find P and Q? So it's actually fairly straightforward because now we know the form as such, right? We know that Sn is Pn plus Qn squared. So when n is 2, we have P times 2 plus Q times 2 squared, right? And this will give us 8. right, as given by the question here. So the first equation will just be 2p plus 4q is 8, and this is our first equation. Now for our second equation would be s5. s5 would be p times 5 plus q times 5 squared, and this will give us a value of 35 at the end, right over here is 35. So when we actually expand this, we get 5p plus 25q is 35, and then this is equation 2, right? So you have two equations over here. You have a pair of simultaneous equations, of which you can key into your GC to help you derive the answer, or you can just key into your normal calculator to derive the answer for you. So in JC, these type of questions, you don't need to write out the steps to solve the simultaneous equation. Like, you just get the value can already, because by the time you reach the JC level, such steps of solving simultaneous equations is considered as very trivial, right? You would want the marks will be awarded to other parts of the question that is more important, right? So we consider this as a trivial step already. So from here, you can just punch it into your calculator to get the value. So when you punch this into your calculator, you will get a final value of p equals to 2 and q equals to 1. That's how we actually derive the answer over here. Now moving on to the next part, they want us to deduce an expression for the nth term of the sequence. So now they want us to derive what is the general term of the sequence, as you can see over here. So how exactly do we derive the general term of the sequence? This is where it's a part that you learn something new, right? So for this double I, I'm going to be talking about this new concept right now, which is actually one of the formulas that you are required to know before you go and sit for the exam, right? So just treat it like a learning experience right now, because I didn't mention this in the previous portion, right? Because in the previous portion, we we're just going through the basics. But now, what Sn here basically entails, right, is that it's the sum of the first n terms. So you can imagine it as u1 plus u2 plus u3 plus dot 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 plus un minus 1 plus un, right? Up until the nth term. Now, what we want to get is essentially the un term over here, right? This is what we want. So how exactly do we get the un term from the equation that we have currently, which is the Sn equation? The only way for us to get the un term would be for us to actually strike out every one of this, right? Because when we strike out, or rather minus away everything else, which is up until the un minus 1, we will get this, because this is the only thing that's left. So in order to get un, I need to start off with Sn, because Sn is the sum of the first n terms. But then I need to minus away Sn minus 1, because Sn minus 1 over here is basically the sum of the first n minus 1 terms. So Sn minus 1 is u1 plus u2 plus u3 all the way until un minus 1. So you can see that when I take this whole thing here, minus away this whole thing, what's just left is just this, right? So this is the first important formula that will be very helpful for you in exams, which is the formula to derive the un term, the general term. To derive the general term, all you need to do is to just take Sn minus Sn minus 1. Right, the sum of the first n terms minus the sum of the first n minus 1 terms. So given that Sn, I'm just going to write it here. It is given that Sn is Pn plus Qn squared, right? And since we know that P is 2 and Q is 1, we know that this is 2n plus n squared. How about n minus 1? Now the beautiful thing about math is that in order to get Sn minus 1, we just need to replace n with n minus 1, because at the end of the day, n is just a variable, so we can sub it for a different value if needed. So Sn minus 1 is essentially 2 times n minus 1 plus n minus 1 squared. And then if we were to expand this, we'll get 2n minus 2 plus a squared minus 2ab plus b squared, right? And then if you further simplify this over here, you get n squared minus 1, right? Very simply put, you're able to derive this equation over here, which will be very useful for you. So in order to find the un term, I'm just going to write it here. So therefore, the un term will just be the value of Sn. And what's the value of Sn? The value of Sn is this, right? So it's just 2n plus n squared. Then what's the value of Sn minus 1? The value of Sn minus 1 is this, right? So from here, I just need to minus away my n squared minus 1. And therefore, I will get a final value of 2n plus 1 as the general term of this entire sequence. So all in all, this is the answers and actually how we derive them from this video explanation. Let me know if this was helpful, and if you have any questions, do leave it in the comments below. If not, this is the end of the formal definition of a sequence and a series. And in the next video onwards, we will actually start to get into the more technical terms, and as well as practice more exam style questions, right? So hope this was helpful. I'll see you in the next video.